All right, so I got this cinema display sign. It's A4 page size, so it's like 8.5 by 11. Basically, lets you do 3 rows of letters that you stick onto it, kind of like those old signs out on the street in front of old buildings or whatever. Um, and it had a 9 volt battery section in it, so I added a 9 volt jack to it, and then it was like, oh, let's make this web controlled. Now I want to point out that it is almost totally pointless for most people to building their own IoT things anymore. You can basically buy a Sonos switch, or you can buy other pieces now that do everything you need. The fact that you build out your own piece is sort of just because you want to do it, right? It's almost always either cheaper or easier or more supported if you buy something. But if you do your own, you can introduce your own security vulnerabilities, or you can try and keep it patched. I don't know. But like everybody else, I like building my own, so I just want to talk about it. So I had this Link Sprite board that would fit in an Altoids tin. And let me show you what the circuit looks like for this. So it turns out this is really freaking easy to do. Oh, I shouldn't have said that. Okay, so this thing's 9 volts. The ESP8266 in here is 3 volts. It's on a 5 volt card with a regulator. I really didn't want to have a second power supply, so what you see here is the 9 volts coming in. There's a tap power regulator in the box that will take it down to 5 volts for the card I got, and then through the relay that's on the board, it'll actually pass through the 9 volts to the display. You can see it's really bright. This is going to blind everything, right? So there you go. And this is the Altoids tin. And that's the picture. So what does the circuit look like? Super simple. So this box here and this box here are actually on the same board. They came with the Link Sprite. It's in another picture. I don't think I have... oh, you'll see it in a minute. Actually, I can show you right now. So this is the Link Sprite board. It's a single relay. They also make a 4-relay board that you could do this with. But I only got the one because it's what they had in stock at Micro Center, and I didn't know they had a 4-relay. So it basically emulates the Wemos. You know what? Let me make this a little bigger. So it emulates the Wemos D1. It's still blurry now. Okay. And it's got a single relay on it. And then I used an electronic battery eliminator for the kind you put in a helicopter or RC control. And it'll take big battery packs down to 5 volts for control. And that works great for me. So that means the jack here that brings the input voltage in for the cinema sign could be anywhere from 6 volts to 24 volts, right? And then we'll tap that down to 5 volts for the ESP8266 board and the relay, and we're good to go. So this thing's kind of cool. It's a DC switch relay, and it's self-powered, right? Which is kind of what you would buy if you bought a Sonos or something, but not being line-powered. This is kind of interesting. So there's 2 jacks here. And basically the idea is when the relay is closed, the hot jack on this side gets connected to the hot leg on this side, and you have power going through, and then the cinema sign gets the power. The grounds are connected all along, and then there's a voltage regulator in here to drop the voltage to feed the Wemos board, right, the LinkNode. So the only thing I did that's kind of interesting here maybe is I put 2 diodes. So these will actually drop you a volt, 1.2, something like that, or 0.7. I don't remember which ones I put in. But basically, that means either of these jacks can be the power, and either of them can be the tap off to the cinema display or other sign. And I did that just because that way I didn't have to worry about an in and out and blow something up. So I diode protected this. So no matter which side the power comes in on, you're good, and the regulator will be powered, and it'll just get passed through, right? So if we look at the board real quick, the box, what's in the Altoids tin, it's crowded, but not super crowded. I picked it because the Altoids tin was tall enough to get the relay in. So I hot glued the board in because hot glue is my best friend. Basically, what you're looking at here, you can see both these pictures. So there's this EBC. So basically coming in from the 2 jacks, you see right here, there's a diode here and a diode here. They're soldered together with a red line that comes into this EBC, electronic brake eliminator circuit. It means so you don't have to have a second battery for your remote control system. And then there's a goes out on this thing that has a little toroid to keep the noise down a little bit. And I just didn't feel like putting it into the 5 volt jack, barrel jack on here. I just popped it right into the ground and 5 volt connectors in the power array. So this power array here is ground 3.3 and 5. So the 5 would have been directly wired off the jack, and then there's a 5 to 3.3 volt regulator here. So this would actually give you 3.3 volt sensors if you wanted to. So you could add additional sensors to this. The one interesting thing about this board is on the 4 relay board, it's not much available, but on the 1 relay board, you get like 5 extra pins that come out here, an analog in and a bunch of other I/O pins. All right, so that's what you got. It's super simple. I don't think I have any more pictures. Oh yeah, these are the 2 jacks. So I bought a pack of 10 jacks online, and basically they're the 2.1 by whatever, the standard barrel jacks. And they happen to be sized pretty well. They go right in the tin. I filed them down a little bit so they fit under the lid. And then if you look on GitHub, the code for this is right there. And that's it. Have a great day.